head containing all the energy and matter in the universe. Suddenly it explodes. This explosion wasn't just any explosion, it was the birth of everything we know. This is the Big Bang, the beginning of everything we know. From this singular event, galaxies started to form, stars began to shine, and the cosmic dance of creation commenced. The explosion was unimaginably huge and hot. Temperatures soared to unimaginable levels, and the energy released was beyond comprehension. It sent energy and matter flying outwards in all directions like a cosmic firework display. These particles would eventually come together to form the building blocks of the universe. Space itself began to expand rapidly, carrying everything with it. This expansion was not just a movement of matter, but an expansion of space-time itself. This expansion continues even today, billions of years later. The universe is still growing, with galaxies moving further apart from each other. It's like inflating a giant balloon. Everything in the universe is moving further apart. The space between galaxies stretches, making the universe larger and larger. The Big Bang wasn't just an explosion of matter and energy, it was also the start of time and space as we know them. Before this event, there was no concept of time or space. It's hard to imagine, but before the Big Bang, there was no time or space. The universe as we understand it simply didn't exist. This monumental event set the stage for everything that followed. Immediately after the Big Bang, the universe was incredibly hot and dense. It was like a giant bowl of cosmic soup filled with tiny particles zipping around at incredible speeds. This early universe was so hot that nothing we know could have survived. Even atoms, the building blocks of everything we see around us, couldn't exist yet. As the universe expanded, it began to cool down. This cooling process was crucial for the formation of everything we see in the universe today. Imagine a pot of boiling water. As it cools, steam turns back into water. In a similar way, as the universe cooled, energy began to transform into tiny particles. As the universe cooled, energy began to condense into tiny particles, like droplets forming from steam. These particles were the first building blocks of matter. One of the first types of particles to form were quarks and gluons, which would later combine to create protons and neutrons. These particles are the building blocks of atoms. At first, these particles were moving too fast to stick together, but as the universe continued to cool, they began to slow down and interact with each other. Imagine a dance floor full of people moving rapidly. As the music slows, people start to pair up and dance together. Similarly, as the universe cooled, particles began to form bonds. Section 4. Atoms, the building blocks of everything. Atoms are the fundamental units of matter, the tiny building blocks that make up everything we see around us. They are composed of protons, neutrons, and electrons, each playing a crucial role in the structure and behavior of matter. After about 380,000 years, the universe had cooled enough for protons and neutrons to combine and form the first atoms. This process, known as recombination, was a pivotal moment in the history of the cosmos. It allowed the universe to transition from a hot, dense state to a cooler, more stable one. These atoms were mostly hydrogen and helium, the two simplest elements in the universe, hydrogen with 1 proton and 1 electron, and helium with 2 protons, 2 neutrons and 2 electrons, formed the foundation for all other elements that would come later. The formation of atoms was a major turning point in the early universe. It set the stage for the development of more complex structures such as stars and galaxies, which would eventually lead to the formation of planets and, ultimately, life. It marked the time when the universe became transparent to light. This transparency allowed photons to travel freely through space, leading to the creation of the cosmic microwave background radiation. Before this point, the universe was filled with a dense fog of charged particles that scattered light. This fog made the universe opaque, preventing light from traveling long distances, but once atoms formed, light could finally travel freely. This freedom of light movement was crucial for the universe to evolve and expand, allowing us to observe distant galaxies. It provides a snapshot of the universe at a very young age, just a few 100,000 years after the Big Bang. It's like a baby picture of the universe, giving us a glimpse of what it looked like billions of years ago. This baby picture helps scientists understand the conditions and processes that shaped the early universe. offering valuable insights into the origins of everything we see today. Section 5. The birth of stars and galaxies. Over millions of years, gravity began to pull together the vast clouds of hydrogen and helium gas that filled the early universe. These clouds became denser and hotter, eventually igniting into the first stars. These early stars were massive and short-lived, burning brightly and then exploding as supernovae. These explosions scattered heavier elements like carbon, oxygen, and iron into space. These heavier elements, forged in the hearts of dying stars, became the building blocks for new generations of stars and planets. We are all made of star stuff. As stars formed, they clustered together under the influence of gravity, forming the first galaxies. Galaxies are vast collections of stars, gas, dust, and planets held together by gravity. Section 6. Planets, our home in the vast universe. Within galaxies, smaller clumps of gas and dust began to collapse under their own gravity. These clumps formed spinning disks of material with a star forming at the center. Within these disks, dust grains collided and stuck together, gradually growing larger and larger. Over millions of years, these clumps of dust and ice accreted to form planets. Our own solar system formed in this way, with the Sun at the center and the planets orbiting around it. Earth, our home, is just one planet among billions in the Milky Way galaxy. Planets are incredibly diverse, ranging from small rocky worlds like Earth to gas giants like Jupiter. Some planets may even harbor life, although we haven't found definitive proof yet. Section 7. The universe continues to expand. The universe is still expanding today, billions of years after the Big Bang. This expansion is not just a simple spreading out of galaxies, but a complex and dynamic process that has fascinated scientists for decades. The very fabric of space itself is stretching, causing galaxies to move away from each other at an ever-increasing rate. In fact, the expansion is accelerating, driven by a mysterious force called dark energy. Dark energy makes up about 68% of the universe, yet we know very little about it. Its discovery has revolutionized our understanding of cosmology and has led to new questions about the ultimate fate of the universe. The future of the universe is uncertain, but astronomers believe it will continue to expand indefinitely. This endless expansion could lead to a scenario known as the Big Freeze, where the universe becomes so spread out that stars burn out and galaxies drift apart, leaving a cold, dark, and empty cosmos. As it expands, it will become colder and darker, with stars eventually burning out. This process will take trillions of years, but it paints a picture of a universe that is constantly evolving and changing, even if it is moving towards a more desolate state. However, even in this distant future, the universe will still be a vast and awe-inspiring place. The sheer scale and beauty of the cosmos will continue to captivate our imaginations and inspire future generations to explore and understand the mysteries of space. It's a reminder that we are part of something much bigger than ourselves, a cosmic story that began billions of years ago with the Big Bang. This story is still being written, with each new discovery adding a new chapter to our understanding of the universe. The study of the universe is an ongoing journey of discovery. Astronomers and scientists around the world are constantly observing, theorizing, and experimenting to uncover the secrets of the cosmos. Their work is crucial in helping us understand not just where we come from, but also where we are headed. Every new observation, every new theory brings us closer to understanding our place in the grand scheme of things. The universe is a vast and complex entity, and our quest to understand it is one of the most profound and exciting endeavors of human existence.